Today's lesson is going to be solving by using the quadratic formula. And so by the end of the lesson, you should be able to say that I can solve quadratic equations by using the quadratic formula. We're also going to explore the discriminant today, which tells us how many solutions a problem has without having to solve for the solutions. So first and foremost, we need to figure out what is the quadratic formula. Well, in the most basic terms, it's used to solve quadratic equations. It's a formula that we use to solve quadratic equations with. And it's just one more method of solving. So this chapter we've explored taking square roots to solve, we've solved by factoring, we've solved by completing the square, and today we're going to talk about how we would solve by using the quadratic formula. In order to solve with the quadratic formula, we need to know what it is. And because it's a solving method, we're going to solve for x. And so the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is what we can use to solve for quadratic equations. This is our quadratic formula. Now, some things to remember. Your a, b, and c terms, they come from your equation. Y equals ax squared plus bx plus c. So the standard form of quadratic equations is where we get a, b, and c from. We also need to make sure that our equation is equal to 0 before we choose our a, b, and c. Then, if you would like to watch a video to help you remember the quadratic formula, you can find it at this YouTube link. Otherwise, if you go into YouTube and type in quadratic formula song, it's a short video, but it's a great song. So before we really start to use the quadratic formula, we first want to explore it a bit. And there's two really important things that the quadratic formula can tell us without us even having to graph or actually solve. The first really cool thing is what I have highlighted in yellow. So notice I did a diagonal highlight, but I found the opposite of b over 2a. I saw that in my quadratic formula. Now, if you recall from early in the chapter, the opposite of b over 2a holds very special importance to us because that's our vertex. At least it's the x value in our vertex. So using the quadratic formula gives us our vertex without having to solve it on the side. So that's one really important part. And the other really important part is what's underneath the square root. It's a b squared minus 4ac. We call this the discriminant. And what the discriminant does, it tells us how many solutions we're going to have. And how we determine that is by thinking about what would happen if we would square root that number. Will it give us 2 solutions, 1 solution, or no solutions? And so we have to find this number, this discriminant, and then to figure out how many solutions that implies, we think about square rooting it. So in order to help us remember things, we first are going to look into the discriminant. So the discriminant, remember, tells us the solutions that we could have, how many we could have. So first off, we need to remember what it is. Remember the discriminant is b squared minus 4ac. And a, b, and c come from that standard form of a quadratic function, which is going to be ax squared plus bx plus c. And remember, it has to equal 0 in order to pull out our a, b, and c. Now I said, remember, the number implies how many solutions we have because we think about what would happen if we would square root it. So if our discriminant would give us a positive number, like 4, and we would take the square root of that, we would get for an answer plus or minus 2. So if our discriminant is a positive number, we're going to get two solutions. If the discriminant is 0, it'd be like taking the square root of 0, which is just 0. We would get one solution. And then if our discriminant is negative, it'd be like us trying to take the square root of negative 3, which we can't do, and so we would have 0 solutions. You could also say no solution. But that's how we can determine the number of solutions, just by figuring out the discriminant, if it's positive, 0, or negative. And we can also help the discriminant, use it to help us figure out what our graph would look like. So first of all, let's recall what the discriminant is. Remember, it's b squared minus 4ac. And then we've talked about what graphs look like when they have so many solutions. So, based upon our discriminant, we could have 0 solutions. It could be 0, positive, or negative. If it's 0, that means we have one solution. If it's positive, we have 2 solutions. And if the discriminant is negative, we have 0 solutions. Remember, when we look at a parabola graphically, the solutions are determined by how many times it intersects our axis. So if we look at our first parabola, it doesn't hit our x at all, and so it really has no solutions. So that discriminant would be negative. If we look at the second parabola, b, it intersects our x-axis twice. That means we have 2 solutions, so the discriminant would be positive. And if we look at the c, it has one intersection with our x-axis, which means that the discriminant would be 0. So the discriminant not only tells us how many solutions we get, but we can also then use that to help visualize our graph, where it might lie. Is it going to intersect twice, once, or not at all with that x-axis? So our first examples today ask us to use the discriminant. So remember, b squared minus 4ac, to determine the number of solutions we have to the equation. Whenever I start a problem using the discriminant or the quadratic formula, I always start by figuring out what is my a, what is my b, and what is my c term. And remember, we also have to check to make sure it equals 0. And in this case it does, so we're good to go and pick out a, b, and c. And so it's ax squared, so that's a 1 in front of our x squared, plus bx. In front of our b we have a negative 2, where a b would be. And our c term is the constant, so it's 3. We need to plug this into our discriminant, b squared minus 4ac. And we need to solve to determine the number of solutions. When I plug in my b, it's a negative 2. Notice I'm using parentheses because we need to remember, I'm writing it down on the bottom, that negative 2 squared does not equal negative 2 squared. They're not the same thing if you use a calculator, no matter what your mind is thinking. So we need to make sure we use parentheses. Then we have minus 4 times a, which is 1, times c, which is 3. If I simplify negative 2 squared, that's 4, minus 4 times 1 times 3 is 12, and I get a negative 8. So because my discriminant is negative, I know that there's going to be no solution. Looking at our next problem, we're going to start it the same way. Pick out a, b, and c. A is the number in front of your x squared, which is 1. C we know is our constant, which is negative 15. And now when we get to b, that's the number in front of our x. However, if you look here, we don't have an x. And so because it's not there at all, we're going to put a 0. So now use this information, find the discriminant, and figure out how many solutions you're going to have, and then come back and watch the video. So when I calculated the discriminant for this problem, I ended up getting positive 60, which implies that I will have two solutions.